Everything about Ethereum 2.0 or Serenity. Serenity, commonly referred to as Ethereum 2.0, is an improvement to Ethereum on a number of levels. Its main goals are to expand Ethereum's transactional capabilities, lower costs, and strengthen the network's sustainability. To do this, Ethereum will switch from a proof-of-work (POW) consensus process to a proof-of-stake consensus mechanism (POS). What is a consensus mechanism? Users' emails, names, and addresses are frequently stored in databases used by businesses and organizations. Database computers are often housed in a single place and administered by a one or small group of people known as administrators. A blockchain is a sort of database, but instead of having all of its data in one place and being managed by only a few people, it is distributed among several people and places. In this manner, the network and data are kept operational even if one machine fails. In order for all of these people's interpretations of the data to coincide, they must figure out how to reach consensus on the right collection of information. Some type of procedure is required to get this consensus. To guarantee that the data, in the instance of a cryptocurrency, this data is transactions, remains consistent across all the nodes, individual computers, in the system, blockchains use a variety of consensus processes. Moving to proof of stake. Proof of work was the initial method employed by blockchains. POW calls for computer competition in order for participants to execute transactions and get prizes. This procedure takes a lot of time and uses a lot of energy. Because of this, several more recent cryptocurrencies have chosen the proof-of-stake path instead. In order to enable much quicker transactions and reduced fees, Ethereum will switch to POS in version 2.0. Instead of the nodes vying to win the block by utilizing a lot of power, consensus is obtained with POS by employing an algorithm that selects one node to win a block of transactions. When a node is selected, it creates the chain's subsequent block of transactions. These nodes are typically referred to as stake pools in POS. A certain amount of randomness has been included into the process in some POS blockchains so that older and greater stakes do not necessarily win. So, stake pools, where individuals stake their currencies, replace miners in POS. Similar to how miners join a mining pool to increase their earnings, individuals may stake or deposit their coins with several stake pools. Where can I stake my Ethereum? Despite the fact that Ethereum 2.0 is plainly not yet available, certain firms do let Ethereum owners stake their holdings on the testnet right away. It's crucial to realize that staking your ETH locks them in place until Ethereum 2.0 is fully released. When it is locked, your Ether will receive staking rewards, but stakers cannot remove their ETH from the stake pool. It might be challenging and risky to stake to the Ethereum testnet using a stake pool. It is therefore best left to those who are more technically savvy. The ideal option for individuals who want to adopt a simpler, more hands-off approach is probably to stake on an exchange. The exchanges Kraken, Coinbase, Binance, and others currently permit Ethereum owners to stake include. More costs are associated with staking on an exchange. Typically, exchanges charge 15% or more of the earnings for staking. How it scales. Sharding is a technique that Ethereum 2.0 proposes to use to increase its capacity. Several of the more recent proof-of-stake (POS) cryptocurrencies use this method because it enables them to expand without making significant compromises to security and decentralization. A database can be divided into smaller, more manageable chunks via sharding. The majority of nodes, or computers, in a POW blockchain have a complete copy of the transaction history. Especially with older coins that have a lot of transaction history, this entire history might use a lot of storage space. In sharding, the blockchain is divided up into parallel portions, and nodes are allocated to one section instead of having to hold the complete of the chain's data. This allows multiple transactions to be handled simultaneously, dramatically boosting throughput and transaction speed.